Greetings and welcome, friends. Hey, we're talking about slope intercept form, and we're on page 141. And it says find the slope and the y-intercept of the graph of the linear equation. Notice it does not tell us to graph it, just asking us to find this information. So what we are thinking of is slope-intercept form, y equals mx plus b. The sloppy slope, the steepness of the line is determined by the coefficient of the x when it is solved for y, and yeah, it's simplified on the other side. So that's my m. The b is the y-intercept, the point at which the graph crosses the y-axis, and that includes the sign of this. So if it's a minus number, it includes the negative there. So that is the y-intercept, and that's where we're simply discerning what the slope and y-intercept are for these based on just a quick glance of their equation. That's the benefit, my friends, of slope-intercept form. I just look at it and immediately I should be able to see what we got. Tyler, thoughts? Yeah. So what do you think the slope is for this first one? I agree. And now, yeah, there is no b, and the way we talk about nothing mathematically and assigning a number to it is with the number 0. I like it. If this helped you imagining it this way, y equals 6x plus 0, maybe it would have more, right, explicitly been aware to you, right? Like, okay, the 6 is the m, and the 0 is the b. Okay, but even though they didn't write it, we still have 0 as our b value. Now, this equation over here is, notice, not in the right form. So I cannot start pulling m's and b's from things until I rearrange it. So let's solve for y. I got to move this negative 2x. How could I move a negative 2x? What are your guys' thoughts? I get that over here. I love it. I love it. Plus 2x to both sides. And I write it underneath this, even though it's not a like term with that. I'm just trying to I'm just going to squeeze it right there. So the mx is before the b is what I'm thinking. So let's see. So now I end up with y equals 2x plus 4. So now this is in slope-intercept form. Let's see. Micaiah, could you guess for me what the slope is from this? Yeah, the 2. Perfect. Perfect. And let's see. Let's have Kayla. What do you think the b is? Yeah, the 4. And if this was a minus sign, it would have been negative 4, but just plain old 4 is what we got there. So that was the first step. All right, can I look at an equation and immediately imagine what the slope and the y-intercept are, or would be? What be they? So let's see. Here's last couple examples I'll do for homework, going over it today. It says graph the linear equation and then identify the x-intercept. So to graph this, hopefully, please do not have done the, should I say, intercepts method. Don't have done the table of values. Let's just find our m and our b. So let's find the m for both of these first. Here, m and m. This one's a little tricky. What is the m? Does anyone have a guess? Well, it is in y equals mx plus b form, but the m, is it just like a minus sign? Well, it's actually, 0x's just wouldn't have even been written, but a negative x is the same as if I said negative 1x. Negative 1x. So there was a 1 was hiding there like a hobbit wearing a ring. So yeah, so that was a stealthy m right there. And over here, what do you guys think the m is? Yeah, 1/2. So, and in the world of rise over run, you might have thought of that as up 1 and over 2. So yeah, and also you can write this as a fraction if it helps you for rise and run, thinking of those two things separately. Let's figure out what the b's be. What be this? Yeah, just plain old 7. And how about this b? 3. Perfect. So the b is the beginning, right? beginning, that's where we start. So I'm going to start by plotting the 7. So starting at the origin, it's the y-intercept. So on the y-axis, that's the vertical one. I'm going to go a 1, 2, 4, 5, 6, 7. Right there, 7. Okay? And now the slope is -1. And like I said, if I want to write that as -1/1, I can. And so from the beginning, I move by the slope. So down 1 over 1, down 1 over 1, down 1 and over 1, right? And sure enough, I can generate a whole bunch of points for myself. Why not, shall we? And let's draw a line through those points. So those points are all going to be solutions of the equation y equals -x plus 7. And if I draw the line through those points, now I have a graphical representation of the infinitely many points that are solutions of this equation. So any point on this, so like right here is the point, looks like over 1, 2, 3, 4, 4, 3. All right, so 4, 3 is on the line, and what that's suggesting is that if I plugged in 4 for x, actually let's just do that for funsies. Let's do, so y would be 3. Is 3 equal to the opposite of 4 plus 7? That check out? -4 plus 7 is 3, yeah. So sure enough, this point is a solution of the equation. And so are all of the infinitely many points, even like the weird decimals and square roots and such, that land on that line. Now they asked us to find the x-intercept, identify it. The x-intercept would be where the line crosses the x-axis. And where does that appear to be? It might be a little tricky to count it out. 1, 2, 3, 4, 5, 6, 7. Yeah, so the x-intercept for that would be 7. And that occurs at the point 7, sorry, I almost did it wrong, 7, 0. But we refer to just the x-coordinate of that point as being the x-intercept. Just like this point up here was 0, 7, the y-intercept, but we refer to just the y-coordinate as being the y-intercept. Okay, here we go. Gotta keep trucking. So let's graph this one. The y-intercept is 3. So starting at the origin, go up 3. 1, 2, 3. There's my beginning. Beginning. My slope is 1/2. In the world of rise over run, that means I'm going up 1 and over 2. Up 1 and over 2. All right? So this line is not that steep. Typically a fractional number less than 1 will be a more and more shallow line. So up 1 over 5, like would have been even shallower, less steep. So just, I don't know, pay attention to that. Maybe that'll help you out in the future. So let's draw the line, draw the line. Here we go, we draw the line. And I'll throw some arrows on that just to let people know this is forever. All right, guys, this line goes infinitely in both of those directions. And so, yeah, so here are my solutions, all infinitely many of them. Where is the x-intercept? Well, here's the x-axis, right? That's the y-axis. Where does it appear to cross? I think, oh, let's see. Actually, it might not cross. Let's see. Down 1, backwards 2. Here's a point. Down 1, backwards 2. Down 1, backwards 2. Okay, so it was supposed to hit right there. And that appears to be 1, 2, 3, 4, 5, 6. So it has an x-intercept at 6. Now, if I couldn't read it off of the graph, like if it was going to cross at some weird decimal location, remember you can always find the x-intercept, which they weren't asking you to do this, by setting y equal to 0. Do you guys remember that trick? Yeah, so if I did 0 equals 1/2 x plus 3, let's just see if I would have gotten the same number. All right, I just want to verify this. So this is how we were finding the intercepts back when we were talking standard form of the equation of a line. So -3 is equal to 1/2 x. How would I get rid of that half? Well, it's being multiplied by x, but dividing both sides by half is weird. That's a stack-o-frac. but you can multiply both sides by its reciprocal, or in this case, just 2. And I would end up getting x equals, oh, guys, good thing I checked, because I told you this was 6. That's in the negative x direction. This was the positive. Oh, man, I made a mistake. But fortunately, my additional check found and exposed that mistake. That was completely unintentional. I was super confident. If you go back and listen, I really said 6. So anyway, so thanks for watching, internet friends. Have fun with slope-intercept form. Bye-bye. Bye, everybody. Bye.